We continue with a lecture on current and voltage transformers. The VT is sound and the secondary side is intact. Ensure the primary side of the VT is sound. Check the VT primary injection value through a high voltage test, applying AC voltage to simulate actual voltage, ensuring transformation values. Go to 520 and check the fuse ratings on both sides of the VT according to the drawing. For the burden test, the burden is the resistance on the secondary circuit with rated voltage, expressed in ohms, amperes, or apparent power in volt amperes. We verify the value of VT primary injection through a comprehensive high voltage test where we apply a controlled AC single phase voltage to the bus bar or to a GIS that accurately simulates the real voltage conditions, so we verify the conversion values meticulously until the very last point. Now we proceed to 520. Let's check the fuse ratings on both sides of the VT and verify them with the drawing. The burden test defines the burden as the resistance on the secondary circuit with the rated secondary voltage expressed in ohms, amperes, or apparent power in volt amperes. To perform the test, open the terminal block at the first point in the secondary circuit, apply the rated secondary voltage through an ammeter to the relay devices, multiply the voltage by the ammeter reading to get the burden in volt amperes, and compare this with the nameplate burden value, which should be equal or less. This ensures the VT operate correctly. To perform the burden test, we follow these steps. First, we open the terminal block at the first point in the secondary circuit, then we apply the rated secondary voltage through an ammeter towards the relay devices. Second, we multiply the rated secondary voltage by the value read from the ammeter, and the result gives us the burden value measured in volt amperes. We then take this value and compare it with the burden value on the nameplate, which should be less than or equal to it.
Prove VT necessity. CPC adds to VT. Ensure single earthing on VT secondary. Connect VT to ground. Resistance, 0. Remove earthing changes resistance. CPC evaluates necessity by adding to VT level and comparing phase. Ensure one earthing point on VTs.
Ensure a single earthing point on the secondary circuit of the VT. Connect the secondary circuit of the VT through an ohmmeter to the ground. Resistance should be 0 or buzz. Remove earthing, resistance not 0, buzz gone. Ensure test switch isolates VT from load. Check terminal blocks, wire connections, and flow. We covered practical VT info in substations. Next episode, current transformers info. See you. And the type of connections on the wires for the VT, as well as the flow on the wire itself, where it comes from and where it goes. With that, we've covered most of the practical information you actually need about voltage transformers in substations. Stay with us for the next episode, where we will explain all the practical information you will also need in substations about current transformers. See you soon. Inspiring the revival of a nation